Thank you, Aki. And Jan, when you asked me to give this topic, you caught me at a really good time. I just finished reading this book, Chip War, and I was feeling really inspired to talk on a topic like this, looking at the early days of semiconductor and just the spark that photomask added to the industry that's been lasting now for over 60 years. And this eBeam initiative is really where we're writing the next chapters in this book, and I'm honored to be part of it. My agenda for today's talk is simple. We're going to examine the photomask economy from three essential segments: capital, materials, and software. And I'll share some data as well as observations, but just to be clear, everything I share today will be from this perspective of Micron's Mass Technology Center. All of you may have different perspectives on this, and if you're interested to talk with me about it, please look me up after the conference. I'll close this talk by just summarizing some of the big challenges that we see in the photomask economy for the second half of the decade. Before I begin, I'm going to plug this again. Thank you, Aki, for an earlier plug. I want to mention I recently gave this webinar, and I plug it here because I think it joins up well with this topic of economics. It's available for viewing on the SPI website and provides an overview of technologies being used in modern-day memory mask making. So check it out. And although I think most of you are familiar with Micron, as we've been an eBeam initiative member since 2020, and we actually presented here last year, I just want to take a moment and give you a quick overview of how the mask shop fits within Micron's network. So Micron founded in 1978, and it's headquartered in Boise, Idaho, but we have HVM wafer fabs around the world, including our newest announcements in Boise, Idaho, and Clay, New York. And within Micron, captive mask manufacturing takes place at the Mass Technology Center, which is also in Boise and provides 100% of Micron's worldwide reticle needs. And the advantage to that is exclusive access to the technology required for leading-edge memory, and also control over the cost of reticles produced. So let's get on with the talk and start with a word about cost controls. This projection is through the year 25 to 26, and with the advent of EUV, we're really projecting a double whammy on costs. It's both due to the increase in cost per unit, as well as lower than expected lifetimes in production. And combined through this period, we think EUV masks could have as much as 30x the cost of optical masks with equivalent lifetime. And we might convince ourselves that these high costs aren't so bad because we can often replace 2, maybe more, optical masks with a single EUV mask. But with significantly lower lifetimes, particularly for memory, where we're using reticles over a long period of time, that adds up still, even with a 2-to-1 replacement factor. And you may also say, well, we can improve lifetime. DRAM is starting out without using pellicle, and certainly pellicle will improve lifetime. We believe that as well. But looking at this on the optical side, we've been working 20 years to improve lifetime. And I think on the memory side, with how much wafer volume we run, we probably have some of the longest lifetimes in the semiconductor industry on optical. So it's going to be challenging to get EUV lifetimes up to where we've experienced optical mask lifetime. Now, managing a mask shop with much higher costs like this, it's a big responsibility. That's number one. It's a very big responsibility. And there's also a very big economic mindset shift that has to occur in all state-of-the-art manufacturing facilities. This kind of cost has to intensify as a mask maker, doing all the things we've always done, what we're good at, but it just intensifies it, whether it's improving quality, deliveries, commercial efficiencies. Simply said, the higher costs means the stakes are higher. Everything from capital to materials to software. And as a captive mask maker working within a company, some of you may think, well, the mask cost, the justification for this has been done. There's an ROI that's been calculated. We moved forward with EUV. Is this significant? Is this still a problem? Heck yeah, this is a problem. This kind of cost is a problem. This is not going to stop the progression of technology. That ship has sailed. We're moving in this direction. But it does factor in when we're looking at 193 levels that could potentially go either way. What kind of scale do we want to deploy EUV at? How widely should we use or convert existing levels to EUV? Mask cost is definitely a factor when we're calculating this. So what are some of the drivers of this high cost? First section at the top, capital and service costs versus throughput. Of course, capital and service is a big part of mask making, whether we're talking optical or EUV. But here, we really see a dramatic difference when we're looking at both of those, as well as decreased throughput, particularly on some of the actinic tools, where we may be inspecting at a very small pixel, collecting a lot of information. We just can't go as fast. So here, I'm showing some aggregation of data, particularly for capital and service, where it's very pronounced in the actinic area. And there's more to actinic than just inspection. There's printability, there's phase, there's reflectometry, there's even pellicle mounting that's unique to EUV. And those costs are really rising along with service. On the service side, we've seen cases where service has gone as high as 1 million or higher on an annualized basis, and in some cases, it's going significantly higher. Not saying it's not justified. There's a lot of complexity in this technology. There's high-end labor required. And there's a supply chain that's very unique to EUV, and it just costs more, especially during the early days of the startup. But taken together, it's a significant contribution. The second big factor on the bottom that maybe doesn't get as much talk is facility space. The tools are getting larger. Again, it's very specific in the case of actinic, or very acute in the case of actinic. We see this growth moving from DUV, shown here for inspection, to eBeam to APMI, and a tremendous growth on the printability tool. Now, most mask shops weren't designed to handle this size of equipment, which equals expansions. I think we all can understand that with the semiconductor industry expanding as rapidly as it is, this kind of need for more facility space would likely happen with or without EUV. But when you have such significantly larger tools, they have to take much more of the allocation of the facility cost. Not to mention the cost of building a facility has gone up significantly. The next factor we see in the modern mask economy has been discussed many times in the industry, not just for mask, but for semiconductors overall, and that's longer lead times. But within the mask industry specifically, I'm highlighting two effects here. One is what I call a baseline equipment effect, and this has really been going on since COVID, where we've seen supply chain issues, even for legacy equipment like CD-SEMs or registration, where technology hasn't significantly shifted from 193. But the EUV equipment has some additional causes, some unique causes. Complex technologies, limited supply chains, maybe single sourcing in many cases, supply chain bottlenecks, and of course, the cost that we mentioned earlier. We don't see equipment just being built on spec, but being built to order, which naturally then triggers the supply chain to start building to order, and everything takes longer. And we think some of these additional causes on EUV are likely going to persist for longer than what we would call here baseline causes. For the mask shop, you can just say, well, longer lead time, just place the PO earlier. But it adds significant risk to our decision making, right? The semiconductor industry is changing frequently, changes direction. It's difficult to forecast even a year out. But when we start looking 2 years out, You start having to place those POs 2 years out. It makes it difficult where you could potentially make a missed call. Receiving equipment too early can be very damaging to cost per unit because you have to amortize that over whatever you're producing at the time. And if you haven't yet ramped or need that technology, you're applying costs which doesn't need to be there. And so this has to be managed, and it changes the calculus of how we think about our interactions in the supply chain. For Micron, it drives us deeper into collaborations with our suppliers while also seeking just improved commercial terms. Partnership. It really becomes more than ever about partnership. State-of-the-art development can't be done alone. We have to have intense collaborations, both technically and commercially, with suppliers and even with our broader semiconductor fabs around the world. At Micron, these collaborations are getting more specific as DRAM advances, as DRAM has some unique patterning shapes and unique specification requirements that may not exist elsewhere in the industry. Technology has to be optimized. I mentioned this in my webinar, where masks have to combine with resist, writers, calibrations. Even mask-specific corrections have to be dialed in for registration and CDs. And today, we extend that further to curvilinear patterns. And those as well, we see uniquenesses on the DRAM side. So by partnering overall with hardware, software, material suppliers, aligning capability for DRAM, we can start to tune this supply chain in to optimize for things like local CDU. Wafer fab, reticle equipment demands. Wafer fabs for years have always had some kind of reticle handling when reticles arrive. Maybe they inspect the reticle. Maybe a few wafer fabs could even repellicle a reticle. But mostly, the work about managing defects on reticles would be done within the mask environment where we had the more sophisticated tool sets. Micron's manufacturing includes EUV wafer fabs spread across what will eventually be multiple countries and cities, while mask shop operations occur at our headquarters in Boise. And what that means is the reticle equipment required to maintain EUV masks so we can get those longer lifetimes, things like cleaning, particle inspection, particle removal tools, pods, even eventually pellicle support, is going to have to be moved into a mask shop, from a mask shop first model to a wafer fab duplicate model. And this is creating a level of scale in our economy that really didn't exist on the optical side. This kind of scale now raises the stakes, not just for equipment suppliers that have opportunity to put more installations in, but also material suppliers, where we see EUV pels, due to the lifetimes of those pels, likely needing to be changed maybe more frequently on the wafer fab side than we even would see on the mask side. The bottom line is developing these technologies leads us to have a wider scope of responsibility, where we're evaluating not just for mask making, but we're also evaluating these tools for how well they work inside the wafer fab to manage mask lifetimes. Talking about mask materials, we have a similar stakes are higher argument with materials, although the factors driving it are a bit different. And materials costs didn't just increase. They jumped an order of magnitude when it comes to EUV. And unfortunately, unlike capital, which gets depreciated over more and more masks as you get volume, with materials, it's one for one. And for those very rare cases when we may scrap a mask, that material cost doubles or even triples if we're having difficulty with new patterning. So we have to consider this in our evaluations. And don't get me wrong, in some ways, material prices can be reasoned as needing to go up. I mean, when we look at a mask blank, we're going from something that today looks pretty basic at 2 to 3 films to have over 80 deposition layers on an EUV mask, not to mention extremely stringent requirements on the ULE substrate. So some of this can be reasoned as needing to go up, at least in the beginning. But requirements are tight on the mask maker side as well, and we need to be looking at how to qualify these materials at a lower cost. One eye-opening event that Micron had when we were working to develop attenuated EUV blanks was this whole idea of TNO qualification, where you can't actually develop a blank and put it into a scanner without going through what ended up being a very significant cost for new material development. Now, on the resist side, it's also gone up somewhat, and we wouldn't really consider there to be an EUV-specific resist. Certainly, low sensitivity resists are being used, maybe exclusively for EUV, but it tends to have crossover onto optical, and that helps us to spread costs. But we still see with EUV, with resist that we're using for EUV, these advanced polymers and components of the resist does drive the cost per bottle up. And some of that, you could argue, might go away as we get maturity, but with resist, it tends to transition to the next generation before we can really reach that point. Before I leave here, I'll just mention on the PEL and pods. First, on the PEL side, this has gone up significantly, but this is an amazing technology. I can remember when the industry first started talking about EUV and folks would say PELs were impossible. That was my impression for many years. I was told that early on that PEL wouldn't be done. And with ASML's innovation and Mitsui's commercialization, we're able to have access to pellicles today. A pellicle is much more than the cost per unit. Like on EUV masks, this will be a double whammy because of the lifetime of pellicles and how long we're able to use a pellicle for on optical. I'm not really sure if we'll get there on EUV. So pellicle cost per unit, hopefully we will see come down as scale goes up, but we will overall have a much higher expense there. And finally, pods, similar story with precision, has gotten a lot more significant as we went to this pod-and-pod design. But both pods and PELs really generate an economy on their own, which I'll talk about here. Within memory, EUV pellicles are primarily looked at from a cost-benefit perspective. That's going to include trade-offs operating with and without a PEL. And I just wanted to take the opportunity to peel back the curtain and take a look at some of the factors that Micron is looking at. Some of you may say, oh, we thought DRAM is not using pellicle, and that's true. We're going to start without pellicle, but it doesn't mean we'll never use pellicle, and it doesn't mean we might not want to use pellicle in certain applications. So pellicle is an important material supply for us, and these are some of the factors that we look at when considering should pellicle have a positive net benefit for the company. We have to look at unit costs. It includes things like lifetime of the pellicle, but also consider inventory space. These pellicles, both receiving them on large pallets because they're extremely delicate, and then shipping them out takes a pallet as well to keep them from being damaged upon shipping. There's also trade-offs on the mask and scanner, with the obvious one being reduced scanner throughput, not just from transmission loss, but the risk of pellicle shattering in the tool has to be considered. So of course, there's benefits on the longer mask lifetimes mentioned before, and less need for frequent defect checks. But ultimately, we have to look at the lifetimes and the damage risk. And maybe by the time the industry does get to CNT-type pellicles, it could tilt the scale more clearly in favor. This is a great slide that one of my colleagues in Taiwan had provided for me. This picture on the bottom is the actual implementation that Micron did with automated reticle handling, overhead handling in the wafer fab. And maybe some of your fabs out here already do this. But at Micron, we really could never find a good ROI for installing all of the overhead, all of the software that comes with delivering reticles to the scanner, to the stocker, to the inspection tool, to the cleaner. But with EUV and the cost being significantly higher, suddenly the ROI is there to do this. Now, when I started in the industry, I worked in a wafer fab, and I was handling the reticles just by hand and carrying the pods from place to place, and with some generous engineers from Photronics, and they taught me how to use a pick. But today, to see this kind of stuff, this is on my bucket list to hit the next time I go to Taiwan and see how they implemented this overhead carry. The efficiency gains just make a lot of sense when we're dealing with high-cost EUV reticles and high-cost scanners and needing to swap them between inspection tools and scanners and back and forth. Software. Now, software has been obviously in the mask industry and used by the mask industry since the invention of photomask. There's been one way or another the use of software. And there's been a lot of leveraging of software from the broader semiconductor industry, kind of making it fit into the mask industry. And there's also been cases where the semiconductor industry has been able to make use of software because of their large scale, and it just never made sense to do it in the mask industry. Things that I show here are some of the presentations that Micron has given at the last few years of Bacchus, where in these cases we co-developed with KLA some sophisticated software to manage information coming out of our line in the back end, joining up inspection and blanks and repair and aims, so we can get very good overview and be able to troubleshoot defects a lot faster. As EUV raises the stakes, the ROI for this type of software suddenly, goes from, wow, a year's license might be paid for by avoiding one scrap mask. Suddenly, software of what was previously a fairly high expense and didn't really have the scale to justify can be justified. And I think it's a real positive for the industry in this manner that we're operating, and we hold the responsibility of a much larger scale economy for photomask. So I'll close with just a few thoughts on the future, and really the future as far as we can see it over the next, let's say, 5 years. We see an introduction of high NA, and there's been talk as well about hyper NA on EUV. And there's certainly a lot of eagerness here, and there's plenty of great papers at this conference. But as of right now, we're not seeing nearly as significant of a shift when the industry moves to high NA EUV. An overall shift in the mask economy may be more of just an evolution of what we have in place. There's been some talk at this conference at perhaps moving to a larger mask size. That would, of course, be a big economic disruption to the mask economy. But generally, I think if we get there, it'll probably be beyond the visible future, maybe into the 2030 range. What we do see very clearly is continued pricing pressure, particularly driven by high-end materials and equipment that's needed to meet next-gen specs. And this is going to create new cost challenges for the mask makers. Sometimes we get one area cost down, and then a new version of materials comes out, and the cost again starts high, and we can work it down from there. That just drives us to what I said earlier, which is that deeper collaboration model with our suppliers. And finally, a word on software. With software, we expect a strong drive, and increased security is one area that will likely get more attention, particularly as mask shops are able to aggregate data, put data in even one location, and start making decisions off of that data. The security becomes a very high level, since you could also lose data very quickly in that manner. And this may be driven both by corporate IP protection as well as government standards. And what we're seeing with the government's involvement in the industry could start to influence that. And so for all reasons mentioned, we have a stronger than ever argument and ROI to drive mask shop specific innovation, custom software for the mask environment in the future. So with that, I want to say thank you very much to Aki and Jan for inviting me to speak here today. I want to say thank you to all of you for listening and all the conversations we've had in the hallways through this conference. If any of you are really interested in this subject and have your perspective to share on how you see the photomask economy evolving, email me, gscheid@micron.com. I'd be happy to talk with you. Thank you.